Welcome to Evolving Angular for the Long Run. My name is Jeremy Elbourn, and I'm the technical lead for Angular, and I have been on the Angular team for just a little under 10 years. And it's really something that I'm here talking about Angular in 2024. The project has been going for quite a long time, especially for the web ecosystem, and there's been a lot of changes over the years. Or to be specific, 31,293 changes, give or take an AngularJS worth of commits. And there's a lot of stories in that commit history, a lot of lessons learned along the way. There has been some hate. There has been a lot more love. And all of that has taken us to today, where the community is saying a phrase, Angular Renaissance. And so I thought it would be interesting to zoom out a bit and talk about how the Angular team approaches evolving the framework, so that we're still talking about Angular in another 10 years. To really understand how we came to our approach today,
Hey,
it's helpful.
Jeremy, could you reshare your slides? They don't seem to be progressing.
Oh, they are not updating. Okay. So,
They seem
so
to be moving now, so I think it's okay.
they're not, okay. So these are swapping?
Yep, I'm seeing
Okay.
things change. Yep.
Okay. We can blame that one on Google Slides. We'll take that hit. Okay. So, going back to what I was saying, to really understand how we came to our approach today, it's helpful to look back in time to some of the big lessons that the team has learned over the years. And from those lessons, we can get into some big picture takeaways that give us a template for our work today. And finally, how these things all distill into practical strategies that we use every day, with some examples of how we've applied those strategies recently. So there have been a lot of places where we've learned lessons over the years. Some come from studying computer science. Some come from seeing what others in the community have created. But for today, I want to highlight two particularly noteworthy periods of time in Angular's history. For our first stop, we can look at the transition from AngularJS to Angular. And I'm not even going to get into the naming confusion. We're going to use some old logos here since we're talking about old versions. And I'm guessing many of you are familiar with this period, but it has been 8 years, so I will give a summary. If we go back in time to the period of around 2012 to 2014, when Guardians of the Galaxy topped the box office and people were still obsessed with Game of Thrones, a novel web framework called AngularJS was becoming super popular, even though AngularJS was originally designed as a rapid prototyping tool rather than something to build production applications with. Developers fell in love with how easy it made wiring up highly interactive experiences. And tons of developers embraced this new way of writing web UIs. But even in that short time period, some limitations became apparent. And there were questions about how much more the framework could be. Could it be faster? Could it be safer? Could it just do more? And these reasons, among others, led to a rewrite. And this is where we came to Angular as we know it today, or at the time as it was called Angular 2. And this was a complete rewrite of the framework from scratch with very different goals and architecture. This rewrite was very ambitious, and it included all the same features as the original in that had a runtime, forms and router support, UI components, and an HTTP client, and an animations module, and quite a bit more. There was the introduction of a compiler and support for SSR, both the TypeScript and Dart programming language, and accommodations for native applications and service workers. And all of these things together made a framework that was pretty radically different than what came before. So what did we learn from this big experience? First is that backwards compatibility is table stakes. Because the rewrite was so different, the jump to Angular was too costly for many developers. While there was an interoperability layer between AngularJS and Angular, that left developers in a state where now they have two frameworks that they have to think about on their page and made their lives a little bit more complicated. And there wasn't much help or tooling for actually converting AngularJS code, which left a lot of developers feeling stuck. This transition could have done more to bring AngularJS developers along to the new version. The second lesson here is that the second system effect is real. The idea was originally presented by Fred Brooks in his 1975 book, The Mythical Man Month. And I'm paraphrasing here, but the idea is that you have some system, and that system, it has some problems. You see over time where it starts to fail. And you dream up a brand new system without these problems. And you spend a long time building that new system. And it's hard. You encounter unknown obstacles and challenges you didn't foresee, but you persevere. And at the end, you have a new system. And it did solve some of those original problems, mostly. But you now realize you've introduced new, different problems. The fallacy here is that in applying new, unfamiliar techniques to a system, you easily fall prey to new design flaws and pitfalls with those techniques. And we definitely saw these outcomes play out with Angular. One specific example, the team had very little experience in building compilers or working with build systems, and that led to the very first versions of Angular having made some architectural decisions with the compiler that led to slow build speeds and inflated bundle sizes. People undertake rewrites because they believe the end state will be better, but a lot of the time, the new system is just different. Software engineering is about identifying trade-offs and deciding which specific trade-offs make the most sense for a project's goals. And in the case of those early versions of Angular, it became clear that the specific trade-offs were not quite in the right place yet. This leads to the next time period I want to highlight, which is the Ivy project. So around 2018, there was a growing desire to fix some of the architectural challenges in the compiler and parts of the runtime. So the team started working on a project named Ivy to address some of these observed problems. Initially, this was intended to be a relatively modest refactoring of the compiler output. But like countless software projects before it, the scope grew into becoming effectively a rewrite of the framework's internals, taking about 3 years to fully roll out. And while the end state did leave Angular with a significantly improved architecture that we are still building on today, it was a challenging journey to get there. And so once more, I ask, what did we learn? First is to plan for the planning fallacy. Again, I'm paraphrasing here, but the idea is that people broadly underestimate how long it takes to complete a task. And when you have a very, very large project with many tasks, those underestimations can accumulate and projects can drag on for far longer than originally dreamed up. And this one, it's maybe kind of a gimme. If you've worked as a developer for more than 6 months, you're intimately familiar with how bad programmers are at estimating how long something is going to take. But there are steps you can take to help fight the planning fallacy and steps you can take to mitigate the consequences. This is not a comprehensive list, but these are some of the cultural practices that have worked their way into the team's planning over time. The first is to estimate work based on past projects. While people are pretty bad at absolutely estimating work, they're pretty good at making relative comparisons to past projects. The next is to strictly scope projects from the start. And this can also mean phasing projects into smaller pieces, which we'll actually talk about a little bit later. The next is to aggressively reject scope creep. This is something that you have to really be on the lookout, because when you define that strict scope from the start, you have to be mindful that you're not slowly increasing it as you go. And it's important to have a backup plan for when things do go long. And that does happen sometimes, right? Nobody's perfect, and we do end up running long on some projects sometimes. And so it's important not to have all of your eggs in one basket, so to speak, to where you're only working on one deliverable, and that is the thing everybody is waiting on. The next big lesson that we got out of this experience was to never underestimate Hiram's law. So this is a term that was coined by a software engineer named Hiram Wright while he was working at Google in the past. And it goes like this. With a sufficient number of users of an API, it does not matter what you promise in the contract. All observable behaviors of your system will be depended on by somebody. And the Angular team really lived Hiram's law firsthand as they tried to roll out Ivy across all of the Angular applications inside of Google. Even though It was mostly an internal refactoring, and even though none of the framework's APIs or main concepts significantly changed, tons of applications broke because they were depending on observable implementation details of the framework. These days, the team is much more deeply attuned to the way that code changes can inadvertently cause breakages because of these inadvertent dependencies on observable implementation details. And it's a major factor we weigh as we make more changes. So these are some of the big formative experiences for Angular. And what are our big takeaways that are worth highlighting? So the first is that just knowing about a pitfall doesn't make you immune to it. This is a really big one for me personally, and if you only remember one thing from this talk, make it this. If you take almost any developer, including Angular developers who are on the team in the past, and ask whether a whole system rewrite is generally a good idea, they'll tell you no, of course not. But if you ask the developer in the middle of a rewrite why their situation is different, you will likely get some very plausible rationale. They have their reasons, and it's easy to fall into the trap of thinking, since I know rewrites are bad, I can avoid the pitfalls of a rewrite. But in my experience, knowing isn't enough. You have to be able to apply that knowledge to recognize a situation that falls under a best practice, and then have the conviction to act on that knowledge. It's the difference between theory and practice. And when you're in the midst of your work, it's truly hard to take a step back and look at the big picture, and a real skill to be able to stand up and say, no, let's not do it this way. Let's come up with a different strategy. Our next takeaway is that it's good to be ambitious, but be ambitious in bite-sized pieces. So big, ambitious visions are necessary if you want to accomplish something truly impactful. But if you go and lock yourself into a closet for years on end to achieve your perfect vision, you're not going to end up building the right thing. The world is going to move on while you're working, and you can easily end up building something based on outdated ideas by the time you finish. Getting feedback on your work as you go is also critical. Again, it's easy to end up building something that doesn't meet your goals because you didn't course correct along the way. It's very easy to start off with a clear idea of where you want to go, and it seems like a straight line. But then reality sets in, and as you execute, you can start to drift from this vision as you encounter unexpected obstacles or things that didn't work out the way you thought they did. And it's only by a few degrees at first, but the further you travel and the more adjustments you have to make, the more these errors compound. And even though it feels like you've been going in a straight line, you're now way off target. And so what do you do about this? As you move towards that goal that's far away, it's critical to give yourself opportunities to make course corrections along the way. And in the case of Angular, this means we have a big focus on shipping incrementally and getting developer feedback regularly to make those course corrections as we go. Our next takeaway is that there are no perfect solutions. Everything is about trade-offs and compromises. In its early days, AngularJS was super focused on features and developer experience, and there were some design decisions made that didn't really prioritize performance. In the transition to Angular, the framework tried to be better about performance, but in doing so, it lost just a little bit of that developer experience magic that people loved in the first place. The team didn't have a really formal model for how to think about the trade-off space in which they were working. And so maybe to think about what is a trade-off space, we can look at a simplified model for demonstration purposes. So here we have a triangle where the points of this triangle are performance, developer experience, and platform scope. And there's a saying I like: all models are wrong, but some models are useful. And I think this model is a useful way of thinking about how you intrinsically make trade-offs as you invest in a project. So say you've landed on a certain point in this trade-off space, right? You're pretty close to developer experience, but you're pretty far away from performance and, a little bit of the way towards your platform scope. We could direct some energy here towards one of these points. We can move towards performance. And doing this changes our trade-offs. We have moved closer to the performance point, but we have moved further away from the others. And this move here, it can be technological. It can be related to the architecture choices you're making, but it could also just be related to opportunity cost, right? Time that you spent investing in performance is time that you're not spending investing in developer experience. And so you can come up with kind of a gradient that you apply over your trade-off space to help decide where you want to be in that trade-off space to guide future decisions. So for colorblind readers, the top left of this triangle is green with a gradient turning to orange and then red as it moves down to the right. Where the green here, the idea is you kind of want to stay inside of this green space and be mindful of any decisions that would take you outside of that. Our next takeaway here is that we don't want to have any concept of you're holding it wrong with Angular. Thanks, Steve Jobs. In its original inception, Angular gave developers a lot of different ways to accomplish a task. And in doing this, the framework maybe made it a little bit too easy to do some suboptimal things that maybe weren't the best performance or maybe weren't the best scalability or maintainability. And at the time, the attitude, I think, of the community more broadly was that every developer should just learn all of the best practices and understand how to tune the system and just always do things the right way. But that attitude doesn't really scale up to large developer populations. Developers generally want to take the shortest path to their destination. Sure, you're going to have some goody two-shoes that take the sidewalk here and walk all the way around and do everything they're supposed to. But with a large enough population, people aren't just intrinsically going to cut this corner and make themselves a little desire path. Even if you put up a sign warning about venomous snakes. And so the takeaway here is that the framework needs to ensure that the easiest path and that the path of the least friction is also the path that is going to give you the best outcome for your application. And finally, our last takeaway is that we need to challenge assumptions about what Angular needs to be. In both the transition from AngularJS to Angular and in the Ivy project, a lot of work was anchored on a very specific idea of what Angular was and what Angular had to be. Coming out of these projects, the team is now very interested in questioning every aspect of the framework. And it has to be this way in order to continue, right? The web ecosystem evolves quickly, and change is necessary to help developers build the best apps possible because what constitutes the best app changes over time. And everything is on the table here, including changing the logo. So we spent a while now talking about the past and some big picture ideas. Let's get a little bit closer, a little bit more practical, and look at some examples of what we've been working on recently and how our practical strategies tie into that. So our first practical strategy is to make evidence-based decisions. And I don't mean you have to write a 20-page report for every commit, but when we're going to make some big change to the way that people use Angular, when we challenge our assumptions about what Angular can be, we better have some compelling evidence to back it up. And we did that recently. So the original idea for Angular's control flow, ngIf, ngFor, ngSwitch, was that they could be implemented totally in user space, and that this was a desirable property without having these APIs need any special access to the framework. But over time, we found that developers really struggled with these APIs. And so we started looking into alternatives and challenging that assumption about the fact that they didn't need special access. And so we recently shipped a whole new control flow API built directly into the template syntax. The if, for, and switch blocks much more closely resemble their JavaScript counterparts. These are more intuitive, they have less boilerplate, and they have better performance guardrails for the for block in particular. And so how did we make an evidence-based decision to get to this point? So we started by running a request for comments, or RFC, on GitHub. And as part of this RFC, we got a lot of developer feedback, concrete evidence that the pain points were real and that people would like something better. And as part of this RFC, the community proposed an alternate syntax that was not in our original pitch. Well, we thought that syntax was very interesting. We took it and we ran forward to collect more evidence. We conducted a formal research study that consisted of a practical coding exercise. 14 participants, both Angular and non-Angular developers, showed a clear preference for the new at-based syntax, the at character. And from there, we polled thousands of developers in our annual developer survey. All of the evidence from each of these steps was loud and clear. People found the new syntax dramatically improved their experience writing Angular code and was a really great success for our strategy here of making evidence-based decisions. Our next practical strategy is to focus on developer intent. That is, when a developer sits down to build some UI, what are they actually trying to do? Which part is hard? And how could we make that easier and more intuitive? And an example of how we have done this recently is with our new deferrable views feature, also called defer blocks. And this is an example where we took a relatively common developer task and built support for it directly into the framework. So in this case, this intent was, I want to defer loading and rendering of some portion of my UI. And sure, people could do this already. You could use dynamic import and add some event listeners and stitch things together yourself. But we saw an opportunity to build an API that would make this easier and directly align with that developer intent. So we had added the syntax that lets you declaratively defer a part of your UI right in the template with built-in support for placeholders and error handling and support for triggers built directly into the syntax. So for example, this code right here uses the viewport trigger, which then under the hood uses intersection observer to load the content when the placeholder enters the viewport. All of this is built directly into the framework, and you don't have to write a single line of TypeScript code to make this work. This syntax has been really successful in accomplishing its goal. We've seen some products inside of Google dramatically reduce the size of their initial JavaScript bundle just because it's so much easier to defer chunks of your initial JavaScript, and developers don't really run into any friction in doing that deferring. Our next practical strategy is to ship incrementally with experimental and developer preview. So I mentioned earlier that we want to be ambitious in bite-sized pieces, and this is how we're practically applying this concept. And I think the best example of how we're applying this is with Angular signals. So we started with a really big, ambitious goal, Angular without Zone.js. And in case you're not familiar with it, Zone.js is a library that's part of Angular, and for as long as it's existed, Angular has depended on Zone.js to drive its change detection. And the way this works is that Zone comes in and it monkey patches a bunch of native browser APIs like set timeout, promise.resolve, add event listener, so that it can know when those events are called, or when those APIs are called. When those APIs are called, Zone can then let Angular know that something might have happened and that it should do change detection. And if Angular detects changes, it updates the DOM. But over the years, a lot of downsides with zones became apparent. It adds some additional bloat to your bundle size. It adds some additional startup latency. It makes debugging more difficult because you've got a bunch of zone frames in your stack trace. It's incompatible with the native JavaScript await syntax. And there's some dissonance with testing because your unit tests don't use zones the same way your production code does, which means that you're not always testing your code in the same way that it would be used in production. So what do we do about all of this? I guess no problem, right? We'll just spend a few years heads down on a zoneless Angular, right? Well, this is live stream, so I can't see your reactions in the audience, so I'll assume everyone is just putting their arms up and yelling, no! That's right, we know we're not going to go down this road. So what do we do? Instead, we ship in phases. So our phase one here was about introducing the lowest level building blocks for this long-term vision. We started with a few simple primitives, signal, computed, and effect. These low-level building blocks were the basis upon which we were going to build a larger reactivity model. So a signal is just a wrapper around a value that you would use instead of raw properties. Angular can know when a signal is read or written and use that information to drive change detection instead of Zone.js. This also gives us more granular information about what changed, so in the future, it can also enable some better performance optimizations. By focusing on this very tightly scoped phase one, we were able to get feedback, build, ship, and make course corrections before moving on to the next step. The second phase built on top of the first, adding APIs for authoring reactive Angular components. This included an API for signal-based inputs. You can think of them as props if maybe you're not super familiar with Angular, as well as model, which is a type of input that supports two-way data synchronization or two-way data binding. We also included signal-based query APIs, which is Angular's way of working with kind of child or descendant elements, and a new function-based output syntax, which is not strictly related to signals, but matches the API style of all of these other signal APIs. And again, this was a very tightly scoped phase of a larger project, which made progress towards our bigger picture goal. And at the end of this phase, developers got some clean, concise new APIs, some new features as well, and the Angular team was able to make any course corrections before moving on to the next phase. So developers are getting value while the Angular team is still making progress towards that big goal. And phase 3 catches us up to where we are today. We have some new APIs that are experimental, have landed just in the last few weeks. We have Resource, which is an API with working with any kind of asynchronous data, most commonly data that you're fetching from your server. And we have link signal, which is an API that combines writable state and derived state. Now, it would take a bit more time than I have today to dive into these APIs in detail, so make sure you follow Angular's version 19 updates to learn more. But these APIs came about due to the team observing production usage of Angular signals and seeing the need to fill in some gaps in order to improve the experience. This was a course correction. Now, I mentioned that for each of these phases, we were able to do these course corrections along the way. But how could we have done that if we had already shipped the APIs, if they were being used in production? Well, we've done this by taking advantage of experimental and developer preview labels for certain new APIs. You can kind of imagine the pipeline like this. We have phase 1 starts in experimental, moves into developer preview, and as that's happening, we can already pipeline getting started on phase 2 and starting to introduce more APIs as experimental. And all of these can move together so that we are pipelining a set of changes through experimental to stables, gradually ramping up that stability to make those course corrections I'm talking about, based on developer feedback and based on usage and production. And all of this lets us still iterate quickly enough to be making real progress towards those larger goals. And these labels, experimental and developer preview, do a pretty good job of grounding developer expectations. Our next practical strategy is to work directly with product teams to validate ideas and to feel the churn. So as we approached working on Angular signals and zoneless, we knew that moving an existing code base would not be trivial. We talked about different coding patterns and use cases and what people might do with them. But as we talked about in the previous section, just knowing or just thinking about a pitfall doesn't make you immune to falling prey to it. And so just kind of thinking about these use cases didn't mean the team really viscerally understood them or felt them. And so the team made a special effort to go and get their hands dirty with a real production code base. Google Fonts. So the Angular team worked with the Google Fonts team both to adopt signals and to switch to zoneless. And this was a great learning experience and directly inspired several additions to the bigger signal roadmaps. In particular, that resource and that link signal API that we just talked about, those were directly inspired by this hands-on work in the Google Fonts code base and the patterns that they were actually shipping in their production code. This collaboration ultimately led to a successful rollout of zoneless in Google Fonts. So if you go to fonts.google.com right now and you go into your console, you type window.zone, you will see that it is undefined. So hands-on product engagements like this have been immensely valuable for the team in validating that we're solving real problems that hold up in production. And our last practical strategy for today is to provide migration and refactoring tools as often as possible. So time and time again, we've seen that version updates are a major struggle for developers, and our update experience has become a cornerstone of our strategy for helping developers stay up to date. Whenever we make some change that would require a mechanical update downstream in applications, we create an automated refactoring tool that runs as part of ng update when you update your version of Angular. But we go even beyond that now. And as we're shipping new features, that built-in control flow and new dependency injection APIs and signals, we're also building opt-in tools that refactor your existing code to the new patterns. And these tools, they work for the majority of cases, but there are some places where they can't quite refactor your code, where your code is too complicated or the tool can't reason about what the code should be doing or what the right outcome is. We think that most of the time these tools handle around like 80 to 90% of the targeted patterns. And we think that this is a really good compromise that lets the Angular team ship new features and evolve the framework while still giving developers really great tools to stay up to date with these versions. If we were to constrain ourselves to only updates that could be 100% automated, we would be really limited in the kinds of changes that we could make in the first place. So we have learned quite a lot here, but how are we going to continue applying these lessons in the future? We have all of these takeaways and all of these strategies. You probably want to know how we're going to apply these going into the future. So we can give you a little bit of a teaser about at least one of the big things that we're thinking about, a big ambitious goal. So our evergreen goal is to continue making it easier to ship web apps with confidence. And as part of this, right, to make this easier, we're not afraid to make big changes. And one area we've been talking about a lot lately is the component authoring experience. And we've got a lot of ideas. And I do want to emphasize that these are ideas. This is not a announcement that something is happening, just ideas. But to give you some sense, what if you could author an Angular component using a very TypeScript first function syntax, where your component is a function and its inputs are expressed in the parameter space, and your template is defined as a return from that function? What if you could author an Angular component to use a more HTML first syntax, similar to the single file component syntax that you can see in Svelte and in Vue? And let's get really wild here. What if you could define a component with a CSS-like syntax, where you have a rule and it has properties? Okay, probably not this one. This one, admittedly, is a little silly. But all of these ideas, whatever we do after watching this talk, hopefully you know that they will be incremental, backwards compatible, migratable, focused on the developer intent to solve real problems, evidence-based, and hopefully delightful. I want to thank all of my teammates on Angular for their work. It is an unrivaled inspiration to work with all of you. Thank you to JetBrains for putting together this lovely event, and also for making WebStorm a tool that I truthfully cannot live without. And thank you, viewer, for watching this talk. If you liked what you heard and saw, visit us at angular.dev. That is all I have for slides, and I think we might have some questions now.
You see, great British humor. Exactly what I said. End of slide was just. Before we go into the question, I want to hook into what you just said. I also very much appreciate the very close collaboration that we have with the Angular team. So you, as a representative now, have to accept that thank you from our side. The way we work together is unique compared to other frameworks. So I really appreciate you.
Oh, thank you.
Khalid, you were super active in the chat while I was working on my copy. So do you want to go over the questions?
Yeah, let's go over some questions here. Paul showing how old he is. Does anybody remember @script? I think the Pharaohs were around back then. You don't have to answer that one, Jeremy.
I was there. I was very, very recently on the team, and they were still using @script. And not long after I joined the team, everything got switched over to TypeScript.
All right. Yeah. So yeah, you folks are OGs. You know what the score is with @script. This one is actually an interesting question by someone you might know.
Oh, I don't know. Didn't ring a bell.
Oh yeah. I'm wondering, has the stability and evolution of the web platform itself made it easier to avoid that big rewrite that you were kind of mentioning as a pitfall at the beginning? Especially in the last few years, the web platforms really evolved to have a lot of functionality just baked in. So
Yeah, I think that definitely there is some historic context around those rewrites that adds more color. So I think I am a little bit reductive in the talk about the reasons for why the rewrite happened. And one of the things I didn't touch on is the changes in the web platform. And so around the time Angular 2 was being worked on, we were also looking at ECMAScript. It was 5, right, at that time, or 6? I forget because they changed to 2015 at some point. So we'll call it
Mhm.
ECMAScript 2015.
I want to say
And
5 too. Yeah.
yeah, it was a colossal change to the JavaScript language. It added classes and arrow functions and promises and so much stuff. And compared to, like, if you took code that was like targeting that and compared it to frameworks that came before, the frameworks that came before seemed very out of date. And so these big monumental changes in the web platform were part of the inspiration for like why these rewrites happened in the first place. And I think you're right that the web platform has become a lot more stable, and TC39 in particular in their evolution of the JavaScript language is being much more incremental. So I believe they have learned some of these lessons themselves, and we have these annual updates of small features that is much more digestible by your rank and file developer.
Yep. This is actually a follow-up question, even by me, because it relates to this. But like, when the Angular team is deciding when to write custom solutions for problems you're trying to solve, like, how do you decide when to lean on custom written solutions versus leaning on something that's built into the platform? Signals kind of comes to mind, right? Like, there's been conversations around signals and but yeah, how does the Angular team decide?
Yeah, so if there is a solution in the platform that solves the problem, we will 100% use it and want to use it. And not only that, but several of the things that we have worked on, we would love to see maybe get some traction in standards body. And so Signals is a perfect example of this. Of the team invested a long time in building out the Signals library and exploring the problem space. And our team members, Alex and Pavel, along with another Googler who works on another web framework at Google called Wiz, Jotun, um, they worked together and put together a proposal to TC39 to add signals to the JavaScript programming language. Now, standards processes are very long and complicated, and we don't know if this is actually going to work out, but we think it would be great if signals were standardized. Um, in general, right, we're making a case-by-case judgment on whether any particular part of the web platform does what we need it to. And so, maybe an example of somewhere where we don't necessarily use something in the platform where we could is maybe Shadow DOM, right? So Angular supports Shadow DOM. You can choose to configure a component to render a shadow root and use that for style encapsulation, but it's not the default, right? The default is this emulated mode. And we go with this because we think that the more intuitive thing for most developers is a scoping mechanism that keeps styles within a component boundaries, but doesn't necessarily prevent styles from outside from going into that. Kind of more aligned with the native CSS scoping proposal that's been floating around for a while, but hasn't gotten enough traction to be fully standardized yet.
Yeah, it's funny you say that because earlier our guest Kevin Powell mentioned like by the time the standards body gets to implementing something that everybody wants, by the time people can use it, they forget that it even exists. So there's probably something in the Angular team wanting to get this stuff in the hands of people and using this stuff. And you kind of mentioned that with the migration, workflow that you showed at the end of your talk. So interesting stuff. Jan,
Yeah.
do you have any questions?
I think there's one question we should go over just because like everything is
Mhm.
so super new with Angular 19 now. So Lance asked, do you think resource and RX resource will be able to replace things like Nginx Signal Store by embedding the translation layer in Angular? Which kind of also goes in this direction. Is Angular starting to commit on like a state management solution to some extent?
So I'll say it's not our intent to build a whole state management solution. That's not the goal. The goal is to build primitives and patterns that people can compose into more sophisticated solutions themselves. And so I don't know that I would say replace, because for one, I'm not actually familiar with NGRX signal store and
You
its
should change
features.
that. It's really good. It's pretty good.
But what I can say is that it is our hope that people can take APIs like Resource and build on top of them to get more sophisticated and more opinionated solutions.
Yeah.
And we hope to continue that pattern going forward, where we can give people the building blocks and they build the kind of more specific product level things.
I like that. I'm very excited for what you are working on with forms and the router to make that a little bit more signally. So very excited once the RFC is out there. And truth be told, I'm also excited about the authoring format.
Yes. So hopefully I didn't scare anybody with the authoring format.
I love it.
It is very much a teaser of ideas that we're thinking about, right? None of this is, there's no code written. There's no design
You
box written.
said exactly like this is the way it's going to ship in V20. That's what everyone heard. That's what the Angular team officially committed on here. I will flip